What about the quiz? The video polyatomic ion quiz is on Friday. So let's talk about the quiz, and then let's talk about your polyatomic ion list. All right? Okay, so the quiz looks like this. 40 of the 52 polyatomic ions, and you can get them in either direction. All right? There are 6 different quizzes. 6 different quizzes. So you could get ammonium, and you have to give me, you could get ammonium, and then you would have to give me NH4+. Or you could get C2O4 minus 2, and you have to give me oxalate. Okay? Because you can get it in either direction. Got it? There are 52 of them. There is a Quizlet up already. Well, it's not up yet. It'll be up by the end of the day. I just have to, assign it to you guys. But then it'll be up. Carolina, I will have to give you the information on how to get into Quizlet. I'll tell you, it's super easy. Before the end of the day, before the end of class, I'll just give you a post-it. All right, questions? Yes. Now, I'm going to help you to memorize the 52. All right? So, take out your polyatomic ion list. And what you're going to do is you can take any notes you like as I go, and then I'm going to give you a mnemonic device that one of my tutor girls gave me that I do not like, but she loved it. So it might be a generational thing, a many generations below me thing. But so far, one class said, oh, that's good, and the other class said, no, we don't care, and not one kid wrote it down. So kind of has gone both ways. I'm going to show you how I learned them, which is actually the real way to learn them, and then I'm going to show you this mnemonic device. So you can choose, or you cannot use either one, and you can just memorize them, however you'd like. So the first thing is, ammonium is the only polyatomic cation. All the rest of the cations are single atom cations. See that? So the only multiple atom cation is ammonium. So that may help. The second thing to take note of is that this group here and this group here are monoatomic ions that you get the charges simply by going from your periodic table. So for example, when I count on my periodic table, with the +1 charges, so +1, +2, +3, right? That's what the charges are. So if I look at aluminum, it's aluminum +3, that is +1, +2, +3, aluminum. If I look at, for example, nitrogen, -1, -2, -3. I don't have to memorize these. All I have to memorize is what Miss Paxton told me. +1, +2, +3 share, -3, -2, -1 full. That's all I need to memorize. And I have every single one of these and every single one of these. You will not have your periodic tables on the quiz because remember this is a memorization quiz, so no, of course you won't have your periodic tables, but you will have the periodic tables on the wall, which is just as good because you don't need your periodic tables. All you need is +1, +2, +3 share, -3, -2, -1 full. So I couldn't really give you your periodic tables because then you would just write all this down, and then that's not a memorization, is it? No. So you won't have your periodic tables. You will have the periodic tables on the wall. So really, you don't have to memorize these 2 columns, these 2 groups. You just need to learn that, right? This group here, number 2, exceptions are transition elements. The reason they're exceptions to type 2 is because This one, cadmium, cobalt, nickel, silver, and zinc, are exceptions. They do not have more than one oxidation state. They only have one. And because they only have one oxidation state, they don't need Roman numerals after them. So you have to memorize which one they are, and you have to memorize their charge. So you have to remember cadmium M+2. Because there's no way to know from seeing where cadmium is on the periodic table what the charge is. So these, you really do have to memorize them, unfortunately. And mercury has two possibilities, and they're weird, so you really do have to memorize those, okay? Next, the next group are the type 2s, and these, the only thing you have to memorize about them is chromium, copper, iron, lead, manganese, and tin. Because either you're going to get chromium with the Roman numeral 3, in which case you know it's chromium plus 3, because I gave you the Roman numeral, so you know it's plus 3. Or I'm going to give you Cr plus 3, in which case you know it's chromium with the Roman numeral 3. So the only thing you have to remember is chromium, copper, iron, lead, manganese, and tin. So that if you get this, you remember to use the Roman numeral. Otherwise, you might just call it chromium, and that's wrong. Okay? So super simple. Just remember 6 different elements. That's all you have to know there. I have to use the Roman numeral for these 6 elements. Super simple. Yeah? Next, we get to the hard part, which is this group right here. This is really the hard part of the group, but it's not random. There are some patterns here, so I want to talk about these patterns. So first, we're going to take a look at some of the endings of these polyatomic ions. So we're going to start by looking at the ending 8, as in like chlorate, chromate, nitrate. And then we're going to look at the ending ite. We're going to look at an ending that is hypo, ite, and above the 8, we're going to look at something that's per 8. So first, we look at 8. And I'm going to give you an example of, well, if we use 8, then we find that ite has 1 less oxygen. So if we use 8 as the base, it means that it has oxygen in it. All right? And then ite has 1 less oxygen than the base. Same charge. These all have the same charge. I'm going to give you an example, so just bear with me, all right? Same charge, but ite has 1 less oxygen than the base. Per 8 has 1 more oxygen than the base. Same charge. And then hypo, and see, per comes from hyper, like hyperactive. Sorry, hyperactive. So that's what the per is. Hyperactive, per. So per 8 would be like per over 8. 1 more oxygen than 8. And then ite has 1 less oxygen than the base. And then hypo, like hypodermic, under. Hypoderm, right? Like under the derm, hypodermic needle. Under the skin, right? Right? Hypodermic. So under ite, 1 less oxygen. All right, so let's do some examples. So here is SO4 minus 2. This is sulfate, right? Sulfate. Okay? So now I have SO3, same charge, minus 2. They always have the same charge. What is this called? Sulfite. So look, one less oxygen, same charge, sulfite. Okay? How about this? This is nitrite, and it's NO2 minus. So what if I wanted nitrate? Yeah, nitrate. And what would be the charge? Yes, the same charge. NO, one more oxygen, 3, and same charge. Okay? What about ClO3 minus is chlorate, and I want 2 less oxygens, and what would that be called? ClO minus would be called stillite, but I need 2 of them. Hypochlorite. One less is called chlorite, and another less is called hypochlorite. Still same charge. Okay? So you can see, if you look on your polyatomic ion sheet, you'll see here is nitrite and nitrate. And here is hypochlorite, chlorite, chlorate, and perchlorate. Okay? Now, the next thing is, here's sulfate and sulfite. The last thing on this sheet is you can take sulfate. I can add 1 hydrogen to it, crisscross, and I get HSO4, and I still have a minus 1 charge. Because when I add the 1 H plus to it, I still get a minus 1 charge left over. Because I had a minus 2 charge, I added 1 hydrogen to it, which is a plus 1, so I still have a minus 1 charge. Everybody okay? Now, we don't want to call this hydrogen sulfate, because hydrogen sulfate would be this. I would take H plus and SO4 minus 2, and I would crisscross, and this would be hydrogen sulfate. See that? That's hydrogen sulfate. But I don't want to do that. So instead, I'm going to call this mono, and I know we said don't call it mono, but this is different because this is not a compound. It's an ion. So we're allowed to use mono, and the reason is because I have to tell you that we're only using 1, because that's a specific thing. So monohydrogen sulfate. So when it's ions, you can use the mono. And the reason is because right here with phosphate, where we have a minus 3 charge, we can use 1, or we can even use 2 and still have ions left over. So we need to be able to say 1 hydrogen or 2 hydrogens. Okay? So hopefully this will help to learn these ions. All right? Okay, now let me show you quickly the mnemonic device that my tutoring student showed me. All right, so here's the mnemonic device. You ready? Nick the clam, Nick the clam ate an inch. I did not design this or write this. Nick the camel, well, that's not well done. Nick the camel, there, just change one letter. Nick the camel ate an inch clam. I guess the clam could have eaten the camel for supper in Phoenix. Okay. Now, the way this works is the consonants determine how many oxygens there are, and the vowels determine the charge. All right? Okay, so Nick is for nitrate. So 1, 2, 3 oxygens, NO3, and then the vowel is the charge, -1. Right, see? So what it does is it gives you all the 8s. It gives you all the 8s because you, in order to use the 8 and hypo and per, you have to know what the 8 is. Right? Because not all the 8s are 4s or not all the 8s are O3s. So you have to know what the 8 is. This gives you all the 8s, all the common 8s. So NO3 -1. Camel is carbonate. So carbon, see, carbon, 1, 2, 3, O3, 2 vowels, -2. Inch is iodate. See, iodate, 1, 2, 3, -1. Clam is chlorate, Cl, 1, 2, 3, -1. Chlorate. So that would make supper sulfate. See, S, right? S, 1, 2, 3, 4, O4. U and E is -2. Phoenix is going to be what? Phosphate. P, O, 1, 2, 3, 4. And 1, 2, 3. So you just take the starting consonants of each word, you add the number of oxygens, and then the charge is the number of vowels. And that gives you all the 8s. Right? And then from there, if you need it, if you need it, you can get the ites or the hydrogen phosphates or whatever you need. Some people liked it. I do not. All right, so if there's any questions, then you ask me or email me.